So today we're going to cover Chapter 7, Section 3. Today we're going to learn how to prove that a quadrilateral is a parallelogram. So basically what we're going to see today is we're going to turn all of the theorems we learned yesterday into converses by switching the if and the then. So the first one is the converse of the parallelogram opposite sides. So we learned that opposite sides in a parallelogram are congruent. So now they've switched it, and now they're stating that if both pairs of opposite sides of a quadrilateral are congruent, then you can prove that the quadrilateral is a parallelogram. So you will be given that the two sides are congruent, and then you can show it's a parallelogram. So specifically, from this picture, I can state that if AB is congruent to CD and BC is congruent to DA, and again, the order doesn't matter here, then ABCD is a parallelogram. So both pairs of opposite sides must be congruent to prove that the quadrilateral is a parallelogram. This is our first way of proving that a quadrilateral is a parallelogram. Again, don't memorize the number. You can just memorize the name or what it states. This one is the converse of the parallelogram opposite angles theorem. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. This is our second way to prove that a quadrilateral is a parallelogram. So specifically in this picture, and again, yesterday, remember, these were color-coded. So B and D are congruent. They have the same congruency mark. And then A and C. So specifically from this picture, if you're given that angle A is congruent to angle C and angle B is congruent to angle D, then ABCD is a parallelogram. Now, notice this time, the diagonals aren't drawn in here. So I can actually name these angles with just one letter. If the diagonals were drawn in, then I would have had to have named angle A and C and B and D with 3 letters. But there's only one angle A, one angle B, one angle C, one angle D, so I can get away with naming it with just one letter. So the next slide is actually a new theorem. It's not a converse. This is our third way of proving a quadrilateral is a parallelogram, and it's called the opposite sides parallel and congruent theorem. And what this one states, that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So what we're looking to find is that a congruency mark and a parallel mark are on the same sides, the same pair of sides. So what I can state from this picture is that if BC is parallel to AD and BC is congruent to AD, then ABCD is a parallelogram. So the congruent and the parallel mark needs to be on the same pair. Let me show you an example where it would not be enough information. So for example, let's say you were given a picture like this. And again, we could name it A, B, C, D. And let's say instead, the congruency marks are on A, B, and C, D, but the parallel was on BC and AD. This picture is a fail. There is not enough information to prove that this is a parallelogram. It does not have enough info, okay? It's a fail because the congruency and the parallel need to be on the same pair. So it's got to be and on the same pair. And then one more converse coming up. So yesterday we learned that if a quadrilateral is a parallelogram, then the diagonals have been bisected. Now we have this in reverse, the converse. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And this is the converse of the parallelogram diagonals theorem. This is our fourth way of proving that a quadrilateral is a parallelogram. So specifically in this picture, I can state that if BD and AC bisect each other, then ABCD is a parallelogram. And I can tell that they've been bisected because BE is congruent to ED, and I'm going to add an E in here. So BE is congruent to ED, and AE is congruent to EC, then ABCD is a parallelogram. So two different ways you could phrase what you're seeing in this picture. So if these, then that. And again, don't memorize the number. You're either memorizing the name or what it states. The next slide just has a summary of the 5 ways that I just showed you. This is the last way, the 5th way. Okay, so the next slide is just a summary. It's summing everything up. These are the 5 ways to prove that a quadrilateral is a parallelogram. The first way, this is the definition. The second way, so to show both pairs of opposite sides are parallel. The second way, to show both pairs of opposite sides are congruent. So this is the parallelogram. Opposite sides converse. The third way, show that one pair of sides are parallel and congruent. This was our new theorem we learned today. So this is the opposite sides parallel and congruent theorem. This one's a theorem, not a converse. And then the fourth way, to show that both pairs of opposite angles are congruent. This is a converse. So the parallelogram, opposite angles converse. And then the last one, it's a converse as well. This one, to show that the diagonals bisect each other. The name of this is the parallelogram. Diagonals converse. So the 5 ways to prove that a quadrilateral is a parallelogram. The next slide has the same thing, but it's got a picture with it as well. So the next slide, same thing, just another visual for you. So again, the first one is the definition. And again, don't memorize any of these numbers. You're going to memorize the names or what it states. So when you show both pairs of opposite sides are parallel, that's the definition of a parallelogram. If you show that both pairs of opposite sides are congruent, that's the parallelogram opposite sides converse. If you show that both pairs of opposite angles are congruent, parallelogram opposite angles converse. Show one pair of opposite sides are congruent and parallel, that's our new theorem, the opposite sides parallel and congruent theorem. And then the last one, show that the diagonals bisect each other. That's the parallelogram diagonals converse. So same thing as the previous slide. Now I just have a picture with it. Okay, so the first example, it says to state the principle, definition, or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. So for the first one, let's go ahead and see what they've given us. So for this one, they're giving us that BE is, and we could add in a congruency mark here, BE is congruent to ED, and CE is congruent to EA. Well, this shows me that my diagonals have been bisected. So what I would use to prove that this ABCD is a parallelogram is the parallelogram diagonals converse. For the next one, angle BAD, so this angle down here, let me go ahead and highlight it around, BAD is congruent to angle DCB, which is this one up here. These are opposite angles. So if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. And this name would have been the parallelogram opposite angles converse. And then again, you would have shown that these are also congruent. So both pairs need to be marked as congruent. For number 3, this one is giving us that BC is parallel to AD and that AB is parallel to DC. So when both pairs of opposite sides are parallel, this is the definition. So definition of a parallelogram. And then number 4, when you're given that a side is congruent to the other one, so BC is congruent, let's do another color here. Let's do orange, 1, 2, 3. BC is congruent to AD, and AB, 1, 2, 3, 4, congruent to DC. When both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram, and this would be our parallelogram opposite sides converse. And then the last one, when you can show that a pair of opposite sides, one pair, the same pair, is both congruent and parallel, then we can state that this is a parallelogram by using the opposite sides, parallel, and congruent theorem. So this last one is a theorem, it's not a converse, and it's not the definition. So again, you're either going to describe what the theorem stated as an if-then statement or give the name. Don't give me the number. The next one says, for what values of x and y is quadrilateral PQRS a parallelogram? Well, I know that in order for this to be a parallelogram, my opposite sides need to be congruent. So I'm going to set my first equation. I'm going to set PQ equal to SR. PQ is x plus 9. SR is 2x minus 1. I need to get my variables together. I get 9 equals x minus 1. Add the 1. 10 equals x. So my value of x is 10. Now, I also know that I could plug in. So now I also know that PS is going to be congruent to QR. So PS is Y, QR is X plus 7. I'm going to use my newly found value of X and plug it in here. So Y is going to be equal to 10 plus 7, and Y is equal to 17. So here it just asks you to find the value of X and Y. Now, let's say it said, find the value of PQ. So if that were the question, we would need to take what PQ equals, which is X plus 9, plug in 10, and PQ would equal 19, which is also going to equal SR. So just be careful. On the quiz, all I'm asking for on some of the questions is just X and Y. Some of them may ask you to find the measure of something. So just read the questions carefully. Let's try the next one. Now instead of sides, now we're going to be seeing angles. Now notice all of these expressions were outside and they did not have a degree symbol. On this example, notice all of the expressions are inside the parallelogram and they've got the little degree symbol. Now on this one, I'm going to be using my parallelogram opposite angles converse to show that this is a parallelogram. So I know that these opposite angles are going to be congruent. So I can go ahead and solve for X by setting 3X minus 32 equal to 2X. It doesn't matter how you set it up. So I'll go ahead and subtract the 3X. I get negative 32 equals negative 1X. Divide by negative 1, and X equals 32. I'm going to do exactly the same thing for Y. Set those opposite angles equal to each other. So angle B is congruent to angle D. So 4Y equals Y plus 87. Subtract the Y. This leaves me with 3Y equals 87. Divide by 3, and Y equals 29. So X is 32, and Y is 29. Remember, if they ask you to find the measure of an angle, we would just plug it back in. So for example, if they said, find the measure of angle B, you would take what B equals, 4Y, take 29, plug it in, and angle B would equal 116. And remember, that's going to be the same thing for D. Or if they said find angle C is 2X. Remember, X was 32. So 2 times 32, and angle C would equal 64, which is also going to be angle A. So just read the questions carefully when we take the quiz on Thursday. Okay, so here it wants us to write a 2-column proof. So let's set up our statements and our reasons. So number 1, state your given. Angle ADB is congruent to angle CBD, and angle ABD is congruent to angle CDB. And this is your given. So let's go ahead and notice what they've done. So let's see, ADB is already marked with the CBD. So notice both of these angles are already marked for us. So now, if you recognize what we've got going on here, we're going to bring back our chapter 3. So because these are congruent angles, I can go through here and say that AB is parallel to CD by using this transversal, because I've got congruent alternate interior angles here. And then I can also state that AD is parallel to BC because these are also alternate interior angles right here. So by my alternate interior angles converse, I can show that this side is parallel to this one, and this one is parallel to this one. And that's my next statement. So I'm going to state that AB is parallel to CD, and AD is also parallel to CB, and that reason is my alternate interior angles converse. Chapter 3 again. And now, because I have two pairs of parallel sides, I can state that this is a parallelogram by using the definition. So that will be my last statement, that ABCD is a parallelogram, and my reason is the definition of a parallelogram. So the proofs are going to be super easy as long as you know these theorems and remember some of your prior knowledge. Okay, so here's an additional proof. So I'm going to give you, given that AB is parallel to DC and AB is congruent to DC, I want you to prove that AD is congruent to BC. And I'm going to give you a visual. It may not have the markings on there. You may have to add them yourself. So I'm going to go ahead and add in what they gave me, that AB was parallel to DC and it was also congruent. So let's set up your statements and reasons. So set up a statement column and a reasons column. State the given again. AB parallel to DC and AB is congruent to DC. Given. The next thing I can do is that's enough information to prove that ABCD is a parallelogram by using the new theorem we just learned. And that's what I'm going to state, that ABCD is a parallelogram, and the reason is using the opposite sides, parallel, and congruent theorem. Because now that I've established that this is a parallelogram, now I can go back and do any of those theorems we learned on from the last night's lesson and show that opposite sides are congruent and opposite angles are congruent. And that's what they wanted me to prove. So they wanted me to show that AD is congruent to BC, and that's what I can state now, that AD is congruent to BC by using my parallelogram opposite sides theorem. And that is it for 7-3's notes. The home questions that you're going to need to show work for are only going to be numbers 6, 7, 8, and 9. So these are the questions you're showing work for. So no work for number 6, just show work for 7, 8, and 9.